We're going to be solving trig equations part 2. For the first two examples, we're still going to be verifying, but it's a special type of verification when an angle is a multiple of 90 degrees or pi over 2, then we have a reduction identity. And the reason why is because you've got that pi over 2, and we know that pi over 2 is our quarter mark on our unit circle. And it just makes things a lot easier because it's at that pi over 2, you're dealing with 0, 1, so that's why it makes it a little bit easier. For instance, if I were to have the sine of pi over 2 plus x equals cosine x, my job is to verify that this is in fact true. So you're going to be using your sum and differences, that's what this is, not solving. Sorry about that. Sum and differences. So I'm going to work with the left side. Not much to work with on the right side there, but I've got sine of pi over 2 times cosine of x plus sine x cosine pi over 2 equals cosine x. So I'm going to go ahead and actually reduce the sine of pi over 2 and the cosine of pi over 2. So I'm using my unit circle, and this is why it makes it easier. Pi over 2 gives you that coordinate of 0 and 1. So the reason why this is a reduction identity is because that 0 takes care of something and it reduces what you're working with. It reduces it tremendously. So for instance, sine pi over 2 goes to 1 cosine x plus, I've got sine x then times that 0. Well, it reduces that sine x of 0 because we know that sine x times 0 is nothing. So that's why we just get a regular cosine x times cosine x. And it does, in fact, work out. Just as another example, we've worked with sum and differences, we've worked with the sine and cosine, but I just want to make sure that we've touched base with a tangent. So we're going to do the same concept here. I've got the tangent of x minus 360, and that's going to equal tangent x. Again, we are just verifying. So I'm going to go ahead and use the tangent difference identity. So I have tangent x minus tangent 360 over 1 plus tangent x times tangent 360. That still, of course, equals tangent x. Well, the tangent of 360, again, 360 is a multiple of that 90 degrees. So that's why this is a reduction, because we're basing it off of that 0, 1 coordinate, or it could be, the 1, 0, it just depends. Either way, you don't have fractions and you don't have those square roots within your unit circle. So I've got the tangent x minus 0 over 1 plus tangent x times 0. And that's because tangent of 360 is 0. So what I'm left with then is just tangent x over 1 equals tangent x, which in fact works. There will be times when you do need to solve a trig equation. This is probably where I got that title from, and working with that. You will have a couple different signs, and you're trying to figure out the value of x. Okay, so find the value of x on 0 to 2 pi. Okay, so with this we have sine of x plus pi over 4 minus the sine of x minus pi over 4. And that equals 0. So we want to figure out what that x value could potentially be in order for this to be true. So the thing here, this can get kind of tricky with that minus, so I'm just going to give you a caution. Remember that negative gets distributed when we simplify this. So I'm going to go ahead and use my sum and differences identities with the sign. So I've got sine x cosine pi over 4 plus sine pi over 4 cosine x minus sine x cosine pi over 4. Now this is where we have that double negative, so it's a negative negative, so it's going to actually be a plus there. So that's why I'm saying be cautious with that when you're doing subtraction like that. So we've got sine of pi over 4, and then cosine x, and that equals 0. So now I'm going to go ahead and reduce all of those that actually have a radian value that I can. So with this first one, I get square root 2 over 2 sine of x plus square root 2 over 2 cosine x minus square root 2 over 2 sine of x. Sorry. Too many cosines and sines. And then we got plus square root 2 over 2 cosine x, and that all still equals 0. So looking at this, I'm going to go ahead and combine my like terms. And when I combine my like terms, the square root 2 over 2 with the sine x, those actually just cancel. So then I'm left with the square root 2 over 2 cosine x, and I need to add those together. So what I'm adding, the nice thing is they already have the same base, so I can just add straight across, and I get 2 square root 2 over 2 cosine x equals 0. So from here, I want to get the cosine by itself. Reduce that, and you get square root 2 cosine x equals 0. Divide by square root 2, which technically any 0 divided by anything is 0. So now I'm using my unit circle to figure out where cosine equals 0. And because we're limiting it, we had an interval at the beginning that said 0 to 2 pi, so it has to be within that circle. Sometimes it might just be 0 to pi, so you just need to determine what it is. And we can see that it's pi over 2 and 3 pi over 2. That's our final answers. So those are ways that you can use your sum and differences identities in order to calculate your values of x.